I've been messing around with machine code for a while now, mainly on the ZX81. I've been decompiling old games and programs that I used to use that were written in machine code, and even writing my own little bits of code. It wasn't until my last video that I really found out just how easy it was to create your own code that you could download onto a real ZX81 or onto an emulator. And that's really shown me that, well, it's really helped me to think that there's one real reason why I enjoy doing this, and it's to understand these programs, mainly games, I suppose, but these programs that I used when I was a kid, and this machine that I used when I was a kid. And, you know, it's really interesting to find that writing one of these programs has unknowingly been on my bucket list for many years. And it's quite interesting to find that I'm getting a bit of closure from writing a few programs in machine code. That said, the only program that I've really got any great motivation for writing is a copy of Defender. Like there were many games that I enjoyed on a ZX81 as a child, like Galaxians and Monster Maze, I think were the two main ones. But as an adult, like I'd become aware of this game Defender, and of course I used to enjoy Defender on the BBC Micro when I was a kid. So anyway, I started coding. I'd seen that Mr. Caldwell had written an excellent version of Defender, and but I'd also become aware of Quicksilver's Defender. I became aware of Quicksilver mainly because of their sound card, which used the AY8910 sound chip, which I've played around with a bit as well. But there was something else that was quite remarkable. Well, there were several things that were quite remarkable about the Quicksilver version of Defender. One was it used the sound card, which was amazing. Another was that it was blisteringly fast and really, really playable. But one annoying feature of it, which actually turned out to be quite interesting, was that it used its own display routine. No, dang it, I don't want to tell you that. It had this annoying display that it seemed like they'd wanted the display to be taller so that they could have some ground scrolling at the bottom. I never quite understood this. It did look good for the ground to be scrolling along the bottom, but it wasn't a part of the game. And it didn't really require the screen to be any taller. You could have had a slightly less tall screen. It really wouldn't have affected the gameplay at all. The main thing that having this scrolling screen at the bottom was that it made the game pretty much unplayable on old TVs, because you had to peek and poke several locations in the ROM, not in the ROM, in the memory once you'd loaded it to get it to scan right so that the frame rate would be right for your TV. A real mess. And it was a real shame because it really was the best game, I thought. Not in terms of graphics so much, but just in terms of playability. Anyway, scroll forward a few years, and I've just started learning assembly language again, or just getting into it a bit more. And I start coding Defender, and I've made this really, really bad version of Defender, which I'm calling Space Defense, because you had to change the name of your program, didn't you? You couldn't call it what the original one was called, otherwise you'd be copyright blocked. That's indeed happened to the company Microsoft, like the British company Microsoft, before that American one got discovered, came over and told them to change the name to Micropower. Anyway, I digress. So anyway, I started coding my Defender game, And it's going all right, and I'm learning. You've really only got a couple of registers to work with. The BC register, the DE register, and the HL register. So you can think of that as 6 bytes. You've got A as well, which is a bit of a workspace. But there's a couple of other registers as well. There's the X and the Y, which is another 4 bytes. So on the ZX81, however, you can't use the X and the Y. The X is, I think, completely used up by the system. And the Y is used by the, well, I think they're both used by the video routine. But the Y is less used. But you can't alter it in your code. Because if you do, even though I think it only really contains the number 4000 for the hex number, hex 4000 for most of the time, you can't change it. But then here comes the interesting thing. Here comes the detective story. It turns out that you can use the Y register if you make your own copy, as far as I understand it, of the video routine and include that in your code. And then you can do what they should have done right from the beginning, which is to push the IY register to the stack after the end of the video routine, and then pop it back onto the stack, off the stack, just as they enter the video routine. So I thought about this for a while and thought, that's a lot of work. But then it dawned on me, there is a program I know of that has its own video routine, and that was the original Quicksilver Defender. And the question is, did they do that not just for the slightly larger screen, but did they also do it because they wanted to use the index register? They were clever people, these Quicksilver people. That could be the case. So I need to find out. Both because I want to use it myself, but now also because I just want to know how this amazing program was written. So I doubt there's anything written down about whether they did that, but I can decompile the source code, the P file. But then it turns out it's actually a bit simpler than that, because somebody's already done that. Somebody called Paul Farrow has already decompiled QS Defender. So here we see it is. And he's put lots of comments in here. And we can see that it says, the video driver as per fast mode, own video driver frees up IX and AF prime. IY not corrupted. I'm not quite sure what he means by IY not corrupted, but they have in fact freed up the IX register. And then below it, it goes on to mention what it's using what the code is using the IX and the IY registers for. And so it seems to me that you set the IX register for somewhere in the address space, and then you can use the offset that goes with it to access different variables. And the importance of this is that even though these IX variables are a little slower to use, you can use them in a sort of indirect mode, rather like you can, well, exactly like you can the HL register. So what it gives you is lots of variables that you can access just from one IX register. You can access, I think it's up to 256 variables. The IX register address minus 127 and plus up to a plus 128, I believe. So that must be two's complement of 1 byte. Yeah, so as you begin programming in assembly, you begin to notice that the BC register and the DE register are slightly less powerful than the HL register, and it gets quite frustrating. And you end up overusing the HL register quite a lot and doing a lot of EX, DE, HL to swap the DE and the HL registers. But this IX register really does free things up, and it's great that you'll be able to get back and use it again. So I think it probably just means hacking this QS Defender a little bit until you can work out what the minimum amount of the video driver it is you need. It probably would be quite difficult. But what I also discovered at the first time, which is something I didn't know, which really is going to make writing machine code a lot simpler, is that there's another exchange operator, EXX, and what that does is it swaps the DE, the BC, and the HL register with a set of shadow registers that basically give you another 6 bytes worth of fast register access, which you can also use for holding the addresses of variables or arrays that you're using. And I think what I'm doing at this point is searching down, and I see whether he uses EXX in his code, assuming it's a he, their code. And yeah, there we are in the display loop. So that's a very powerful code, EXX. And then at some point, maybe you could get the IX and IY registers working. On that forum site that I showed earlier, there's a program writer called Samoris, and he mentions a way that you can actually redirect the IY register. And even though the video routine is still using it, you can cleverly reuse it just by noting that it only uses a couple of the indexed locations in the video routine. So long as you change the IY register to something where you've copied the necessary few bytes from the video routine into that area of memory, that your program won't crash. I've not described that very well, but if you go back to the original vlog forum page, it explains it a lot better. So a few more options to give us a bit more flexibility in our assembly writing. Okay, this video has gone on far too long. Hope you enjoyed it.